Hello everyone, I'm Samidha Bardwekar. Welcome to the session on data storage concepts. Data storage concepts refers to the methods which are used to store and retrieve the data on the storage media. So today we will see the principles of data storage, role of data storage devices in digital investigations, analysis of different storage media types, and evolving data storage technologies. So let's start with the principles of data storage. As we have seen in previous videos, data is stored on the disk in smaller units called as sectors, which are further grouped into clusters and arranged on the tracks. So let's explore these terms in case of digital forensics. First is sector. Analyzing the unused sector can reveal the residues of deleted files, like the file fragments. Also, the data which is hidden intentionally using the steganographic techniques can leave traces in the unused sectors, and the overwritten data can be recovered in some cases using data recovery techniques, which can extract the portions of overwritten data from the traces. Next is cluster. As we know, file fragmentation means when the file exceeds the cluster size, those files are stored across multiple clusters. So this can impact the data recovery process. And knowing how the files are allocated across the cluster helps in reconstructing deleted or fragmented files. Next is block. Block is a broader term which includes sectors and clusters. This is used in case of SSD, solid state drives. So understanding the SSD block size is important in case of data recovery, which is done in SSD analysis. The next point is role of storage devices in investigation. Storage media plays important role in digital forensics. So we'll see how. First is evidence storage. Storage devices contains some information which can be considered as evidence in some cases during the investigation. So this can include the files, emails, browsing history, chats, logs, images, audio video files, and so on. Next is data recovery. In the cases when the data is lost, deleted, or corrupted, different forensic tools are used for the data recovery purpose. Next is preservation of digital evidence. So as we have seen, the first step in the investigation process is preserving the original evidence. And this is done by creating then forensic image of the acquired storage media using some tools. Next is evidence analysis. So once the data is preserved, the investigators analyze the data to identify some files in that storage media, which helps in reconstructing the evidences. Next, understanding data persistence. Different storage media show various degrees of data persistence. For example, the hard disk retain the traces of deleted data more readily as compared to SSD. So understanding this can help in data recovery. Next is interpretation of investigation. Storage media contains the data which is helpful in interpreting investigations. For example, the data stored behind an image can recover or reveal the intention of that author to store the data. So this was all about the role of storage devices in the investigation process. Next point is analysis of storage media and their impact on data. So we will see different types of storage media in this. First is hard disk drive. So as we know, the data is stored on the platters across the hard disk and it is read by the moving head. So when the data is deleted or the drive is formatted, the data is not immediately removed from the drive. The areas where the data was stored are now marked as available for reuse. So this data can be recovered until it is overwritten by any new data. And in terms of forensics, understanding these concepts is essential, and various tools can be used to recover the data. Next type is SSD, that is solid state drive. Nowadays, SSDs are replacing the traditional hard disk because they are faster as compared to the hard disk. SSD uses flash memory for data storage purpose. Mainly they use memory chips instead of platters to store the data. So this difference in technology impacts the data recovery purpose. SSD uses a feature which is called as wear leveling. This feature is mainly used to increase the lifespan of the memory chips which are used to store the data. So due to this, the data is constantly moving across the drive and it can increase the challenges in data recovery. SSD uses trim command. This command is used to zero out the data on the blocks when the file was deleted by the user. So these features of SSD can challenge the data recovery process. Next type of storage media is NVMe. NVMe, it is a new type of SSD or advanced SSD. NVMe stands for Non-Volatile Memory Express. It is basically a protocol which is used to connect the SSD server or CPU. So as it is an advanced SSD type, it allows faster data transfer rates. And as like SSD, these drives also uses the common features like wear leveling and trim. So these features can complicate the data recovery process. So some experiments conclude that the file recovery is impacted in terms of NVMe when the files are deleted from the drive and there is no surety of complete data recovery. Next storage media type is removable devices. So the common types of removable devices are USB drives and flash cards. These drives use flash memory for data storage. Flash memory or flash storage is a type of storage media and it is non-volatile in nature. So as it uses flash memory for data storage purpose as like SSD, so some same challenges are faced in case of removable devices for data recovery purpose. Next storage media type is cloud storage. Cloud storage is a unique data storage as it differs from the physical media. And depending on the cloud service and the user's data settings, the data can be recovered from the recycle bin of the cloud service, but in limited time. Also, when the data is pushed from the recycle bin, it is not recoverable from the user side also. So the last point is evolving data storage technologies. First is cloud computing. As we know, the dependence on cloud service is increasing day by day. So the forensic models are adapting for cloud investigations. And some challenges are faced in this, like log access, physical accessibility, and privacy. So the traditional forensic methods needs to be evolved in cloud computing. Next is IoT. IoT involves the objects which are interconnected and those objects are with advanced capabilities. So this is also challenging in terms of investigations. As the IoT is complex in nature, so the forensic methods should be evolved accordingly. Next is remote digital forensics. So the focus of investigation or analysis is shifting from on-site to remote processes. Some tools are used for acquisition and collection of data and analysis of data from remote location. So in remote digital forensics, the maintaining the legal integrity is quite challenging. Next is emerging technology. So new technologies including AI, artificial intelligence, robotics, and drones are changing the way in which we do digital forensics. So these technologies also include new tools and procedures. And integrity and validity of these tools and procedures is important in this case. So this was all about the data storage concepts, in which we have seen the principles of storage devices, types of storage media, and evolving data storage technologies. Also, we have seen the significance of all these concepts in digital forensics. Thank you.